Hi everyone, welcome to another session of our NLP Journal Club. Today we're looking at a paper called Felix, Flexible Text Editing Through Tagging and Insertion by a bunch of guys from the Google research team. So, as you may know, sequence-to-sequence models are predominantly used in tasks like neural machine translation. And the way those models work is, if we take this example figure here, you're given an input sequence like the big, very loud cat, and you're trying to generate an output sequence like the very big old cat. So if the target sequence is in a different language, let's say in German, it makes sense to use the standard sequence-to-sequence models because the way they work is they generate the output sequence word by word from scratch by conditioning on the input sequence. However, for many tasks, this would be an overkill because let's say if we consider the example of text summarization, where this is the input summary and you want to generate, this is the input article and you want to generate a summary. So for that case, the input article would contain basically all words from the summary. And in that case, generating the whole summary from scratch could be considered an overkill because basically all you need to generate the summary is to define a set of text editing operations that rewrite the article, maybe delete some words, maybe reorder some information, maybe introduce some new words. And that's all you need to generate the target output sequence. And this is precisely the setting that the authors consider. They propose a new method to target this text editing approach, which they call Felix. So if we go into the details of this Felix method, here we have a picture which basically illustrates how this works. There are two components to get this going. The first model is a tagging model, which takes the input sentence, the big very loud cat, and assigns a sequence of tags to this sentence, either keeping the words, for example, D is still in the target output sequence that we want to generate, so we're going to keep it, or assigning, for example, a delete token, which will basically force the model to remove this word loud in subsequent steps. Then after you have done this tagging step, there's also a pointer network which essentially reorders the words because, for example, big and very are swapped in the final output sequence. So you're gonna be basically the way this pointer network works is you're gonna compose a sequence that is gonna come up with a new order and saying you're gonna start with D, then with big, then with very, and so on and so forth. Basically preparing this sequence, generating an intermediate sequence that will be used to move us closer to the target sequence, the very big old cat. And then the final step in this Felix model is to use another model, an insertion model, to basically fill in any gaps that might be created from deletion. So basically, this is about generating the word old, which is not part of the original input sequence. And this is how this model works. One nice feature of this model is that you can actually reuse existing pre-trained BERT checkpoints to initialize both of those tagging and insertion models. And actually, for the case of the insertion model, you don't even need to fine-tune, I think. I'm not sure if they fine-tune in this paper, but you may not even need to fine-tune so much, so you can leverage those pre-trained checkpoints. and basically plugging in the BERT model to predict the missing words here. This is kind of hopefully gives you a basic overview of how this Felix model works. And now we're going to go into the details of the experiments. The first task that they test this model on is sentence fusion using a dataset called disconfuse. And in this table here, we have a bunch of different results. We have some sequence baselines, which are generating the output fused sentences given the input from scratch. So these are these first two models. We also have this laser tiger model, which is a model from last year, which is again taking a similar text editing approach with some differences. And there's also a bunch of different configurations of the Felix model. Basically different, they do like an ablation study, they try out different flavors of this Felix approach. And first of all, if you train on the full dataset, what they find out is that actually the sequence approach seems to perform best. However, if you start reducing the amount of training data available to 10%, to 1%, 0.1%, or even 0.01%, you're seeing a stark, very fast drop in performance for the sequence approaches. And actually, if you have only 0.1%, you're getting like 0 basically. But in contrast, the text editing approaches are still able to retain some of the performance, which is quite neat because it means that they are particularly relevant for low resource scenarios. And even you can even get some performance only with 0.01% of the data. And probably this is due to the fact that you're basically not really, maybe in some cases you don't even need to have to change the input sequence so much. And actually one interesting question here is how much is the output sequence changed in those low resource cases? I'm not sure, I don't remember reading that. Maybe it's written somewhere in the paper. But that's basically the finding for this task. And they also test on summarization in this table here, which is again a low resource dataset that they use. And basically what they show is that the sequence baseline here performs much worse than the text editing approaches in terms of rouge or blue metrics, which is nice to see that in this low resource setting, again for summarization, you can have some benefit of using this Felix approach. And then finally the test on the WMT English to German post-editing task. Basically this task, in case you're not familiar, you are given some translations that might be noisy and you are tasking the model with refining those translations to improve their quality. And there what they find is that the full-on Felix model is actually able to kind of match the performance of the sequence transformer models. This is slightly different metrics, so this TER lower is better, this blue higher is better. And again, showing that this text editing approach can be effective in those tasks where text editing seems to be a more natural approach. So this kind of sums up what I wanted to cover for this paper. In overall, it seems to be a nice approach, hybrid approach, which allows you to capture a wide range of text editing operations. So not only just deleting or keeping tokens, which has been covered in some previous works, but even inserting new words. It's nice that you can use pre-trained checkpoints to do this task, so you can leverage large amounts of training data still for this model, and this approach fits naturally in many sequence tasks, in particular monolingual tasks like summarization post-editing, sentence fusion, and so on. So yeah, so thanks for listening, and please subscribe for some upcoming NLP videos coming out your way in the future. Thanks.